Good morning, folks. This is tutorial number 2 in this playlist, which is called Dynamics Scenario in 3D Experience. And it deals with directly inputting the velocity profile of a block that is accelerating along a track. Now, I want to remind you that this was also done in the other playlist, the kinematics scenario, dot, dot, dot. But there, it was exactly the same problem, except that there, I did not input the velocity profile directly. I had to start from acceleration. Given the acceleration, 2 inch per second squared, I said that, okay, velocity is integral acceleration, which is 2t inch per second, and then integrated backwards again to get the position. So I inputted the position because there's no way you can input the velocity in the kinematic scenario creation, or at least I don't know how to do it. I have serious doubts that it can be done. That's why we are going to dynamic scenario creation in this playlist and directly input that velocity profile. Now notice that the velocity profile, this velocity profile implies that the acceleration was 2, but I don't care. This is what I want to input. But you can write this thing in terms of this expression, because you can see that this 2 actually has the unit of 2 inch per second squared, so that when you multiply it by second, you get 2 inch per second. Okay, now uh, when you go and try to create kinematics or dynamics scenarios, it allows you to input velocity law excitation. This could not have been done if you created a kinematic scenario, okay? Now, let me quickly remind you that something weird happens when you do dynamics scenario creation, and that is you have to specify the weight or the mass of the participating object. Otherwise, it's going to come back and give you an error message saying that, hey, you did not specify the mass. And this cannot be done at the part level, etc. It must be done in a very awkward way, as you will see here. I mean, you might say that, well, I put a material on the part when I created it, etc. How come it doesn't take into consideration? Yep, I agree with you. That's why I'm saying this is a rather awkward way of doing it. This has to be done directly by the user. Now, uh, here is how it's going to look like. Of course, I will come back to this slide later on. Let me remind you that I'm inputting the middle formula. Okay, the middle formula. In the tutorial 2, in the previous playlist, I had to do the distance. Okay, I could not do velocity directly. Now I'm going to do velocity directly. But this is where you actually have to specify the properties of that you want. And for example, I'll show you how to get there. When you click that weight icon, you're going to end up here. And if you don't like, these are the properties of steel. This is coming from the default properties of steel. And if you don't want it, you can left click on it and change it to whatever you want. But I will be using these properties. I'm not going to use other material. Okay, so because the purpose of this tutorial is not to do the dynamic problem, it's just show you how you direct input velocity profile. I don't care what the mass was, I don't care what the force is, but if I try to do dynamic and the mass is missing, the way I explained it, it's not going to run. Okay, now this because I'm using slinch, pound, inch, stuff like that. This is really not the weight, it is the mass, okay? And what I'm going to check at the end, one of the things I'm going to check at the end, incidentally, your acceleration should be constant, velocity you are inputting, of course, and if you plot the displacement, it should be parabolic. But there's something else I'm going to change, and that is the force on that block after the simulation. Now remember, basic Newton's second law tells you this, and that is the mass. Acceleration is 2 because of my velocity profile. So if I plug in at the end, I should be getting a force obviously a constant force in this case because the acceleration is constant of that much. That's another check. Okay? All right. Oh, yeah, I mentioned that these are the default, this is from the default property of steel. But since I don't care about the dynamic aspect, I just have to input, I'll just use the same thing, but convert it into slinch. So I've changed all my units in 3D Experience so that the, uh, you know, if I want to see things at the end, 2 pound, inch, slinch, inch per second, second squared, etc. Okay, let's go ahead and do that. Well, let me start with the assembly design. Okay, right click, insert, first do the track. Okay, that's going to be the track. So let me see, properties, track, and track. Okay, let's go make it 21 inches long. On that vertical plane, I will sketch. Oh, on this vertical plane, I will sketch. At the track, right there, I'll make it 1 inch wide. Okay, exit. And then pad it by 21 inches. Good, so that's going to be the track. All the way to the top, insert the block, rename this thing block and block. Let's go make it. On that vertical plane, I will sketch 1 inch by 1 inch. These dimensions in principle don't matter because I'm interested only in, I'm not interested in dynamic aspects, but of course it will affect the force, but all right, good. So let me put this thing over there. Actually, we don't have to do that. We'll do that later. Okay. So exit by 1. Okay. Why don't I bring this thing and put it over there? So I go to where are we? Yeah. So we go all the way to the top. We are in assembly now. I'm going to use a snap to bring it down. Snap this point to this point. Good. Okay. So first thing we're going to do is to actually don't bother putting masses and or density and material on this thing because it's not going to work, or at least I couldn't get it to work. I don't think it will. Now you go to fix the track. So we go here, fix. You're going to fix the track. Okay, it's already done right there. Very good. Now we create a prismatic joint between the block and this track. So let's go and make a prismatic joint. And I'm going to use axis, and then you also have to give it offset to be able to create a command for it. So this and that, this plane and that plane. And because it has, you eventually have to put the velocity on a command, you need to select these offsets. In other words, the distance between these two is what's going to be controlled indirectly through the velocity. And then we say okay, and no. Okay, so this is where the weird thing is, that that weight definition. So what you can do, if you want, you can go to mechanical system experience, but then at some point you have to go back to mechanical system design because that's where that weight thingy is. You click on it. Okay, so first of all, let's create a representation here. Okay, and then notice that what's going to happen here is the representation. Two joints are, one joint is created, it's the prismatic one, the other one is the fixed one, and there is a command here because this command you needed to put the velocity on this later on, although this specifies the distance between the two end faces, but it has to be there, otherwise you can't do velocity profile directly. Now, if you scroll to the right, you're going to see this guy. You see this? Weight definition. And what I'm referring to now is that, okay? You have to be mechanical system design. Even if you skip this step and you went to the mechanical system experience, you will have to double click and come back here and to put this weight on it. Okay, so let's go back there. You click on this and look at this table. It says missing 100%, weight definition missing, okay? So what I can do, I can select these individually, or I can select this whole thing and it's put it on the whole thing. Okay, so you click on it. Now read this thing carefully. Click this hyperlink to define to declare a weight on this element. I mean, obviously, because we selected the whole thing, it's going to do it both is going to be used. Okay, so we click on that, and this thing pops up. Okay, notice that. Let me move these things on the side so we can see it better. This table is almost what I showed you here, except that these are zero. So that's because you can put numbers that you want here, but if you click on this fellow, you see this checkbox here? This checkbox, not this box on the left side. What it's going to do is it's going to put the properties of default properties of steel on it. You click on it, and right there. Now, the one thing is that if I do it like that, this this is going to be the weight of the entire thing, and I don't really want it. I want the weight of this to be properly selected. Okay, so let me close that. Let's try it again. So this is let's click on that and select this track, replace a computed, and click on that. So now it's going to be only, this is going to be only on this, in terms of slinch, it's going to be only on this track. Okay, fine. Let's do it again. That fellow, click on it, click on that, and this is only on that block. So the reason is that later on I need the mass of the block in order to do that calculation. Okay. Now, if I didn't care about it, all I wanted to do was to show you how to plot the velocity and things, or input the velocities. Doesn't matter. But because at the end, I want to check. Through this formula what the force on the block is. What I did, in spite of the fact that I actually initially went and selected the whole assembly, I didn't like it. I came back and said, oh, well, let me redo this thing. I selected the track, which is totally useless, but it has to be done, and selected the block because this is the number that is actually the mass of that block. Okay? Very awkward. Once again, if you're not interested in forces, it doesn't matter what you did. You can put it on the whole assembly, and you get to see how to input the velocity profile, but the force is not going to be necessarily correct. Okay, good. So let me close that. Here's the box to close it right there. See this? Very good. Okay, and you don't see any, and make sure you close that. You don't see, or at least in the tree, you don't see any place to go and check these things. Okay. Likelihood you can find in one of these icons where things are, but anyway. Now, the next thing to do is, the only reason I came here is because I wanted to specify those weights. I go to Mechanical Systems Experience, Okay. Now I don't want to create a mechanism or a kinematic scenario because actually I want to do that was already well. I'm going to use. I'm not going to use a kinematic scenario. I'll be using a dynamic scenario. So this is not check. Say okay. Good. Very good. Okay. Now, first of all, here is velocity profile. See that velocity law excitation. So you go back here. There is the velocity law excitation. You click on it. Now you have to select the support. The support is that command. If that command was not created, you will not be able to pick this. Okay. And then you click on f of x, because this is a very simple formula. It's going to be velocity is 2, let's see how we write it, 2 inch, let me write it like that, 2 inch second square, 2 inch underscore s2. Remember, this is how we're going to write it, times time. Times, I'm specifying the velocity profile directly in this tutorial as a function, formula. In tutorial 3, you can't do it like that. You have to create a rule because the velocity profile is more complicated. So here's the time, double click, and hopefully there are no syntax error. We say okay, yep, and then you close it, say okay. Good. Now we can go and create the dynamic scenario right there. Dynamic scenario. Okay, here is the velocity profile that I created. I send it to the right. For total duration, I'm going to make it maybe 4.8 seconds, and this is it. Now I will create a probe. I don't have a probe here, but I will create a probe. I say okay. Say okay. I will create a probe at this corner. So here's a probe. Probe means that show me the velocity and show me anything that I want can be recovered at that point. Okay. Say okay. All right. So we're in good shape. We have a scenario, dynamic scenario right there. We never did this thing in the before, never in the previous tutorial. The previous tutorial, they were all kinematic scenarios. And that's pretty much it. You go here and run it. Compute. Whoops. I should change the direction of that. Okay, let me go and change the direction of that, or I can either change the direction of that or put a velocity negative, but I will change this direction. Let's go back to this. Okay, right here. This allows you to flip the direction and say okay. And now go back to scenario and run it. This time we'll go to the right. Notice that in this tutorial, I specified the velocity directly. I did not integrate manually backward to find the position. I put the position in it. Okay. Now let's go and check a few things. For example, let's go and check. Let me first of all check the x linear velocity. Okay, where is that? What is that? First of all, the position of that point, the position of that corner point. That's going to be a parabolic. Okay. Yeah. Oops. Sorry, not. Or I selected the wrong one. This is y, I suppose. Hang in there. Which one is the direction? Maybe y direction. Yeah. Parabola. No problem. Because of the way I made it y is in this direction, so y. Now let's go ahead and look at the acceleration. Acceleration, y direction acceleration, that better be constant. What did I pick here? This is velocity, sorry. Acceleration is here. That better be constant. It is constant, 2 inches per second squared. Now, obviously, if I say show me the velocity, it's thing that I inputted. I'm not going to get anything unusual. This is just the velocity which I inputted, right? This is just the velocity. Okay, good. Let me go ahead and do the force. Okay, so let me go back here because yeah, okay. So let me say deselect all. How about the force right here? Y force in the Y direction. 1.45, 10 to the minus 3. 1.45, 10 to the minus 3 pound. Now, in this problem, acceleration was constant. The mass is given here. The force is going to be constant. So, okay, that takes care of this tutorial. Good luck.